Why are some chips pin packaged? The mobile phone uses a bottom BGA ball grid array package. Let's take a look at this chip first. The so-called chip is actually only a very small part in the middle. Take a close look at its structure. The chip is facing upwards, and the internal circuitry is connected to the protruding blocks around it. Then, one by one, wires finer than a human hair are bonded, connecting them to the pins. Then, the housing is bonded for protection. This packaging method is called wire bonding packaging. As chips become more functional, the number of pins around their periphery increases, and the housing volume correspondingly expands. If aiming for mobile processor-level chips, the chip alone would likely end up as large as the entire mobile phone. Clearly, this packaging method is unsuitable. Now let's examine how another packaging approach addresses the volume issue. When disassembling the chip housing, the die is found facing down with an array of solder bumps covering its entire surface. These protrusions are tightly attached to a wire-conductive substrate. Pay attention! The circuitry on this substrate is interconnected to the opposite side through laser-drilled microvias. Then implant metal balls. The chip relies on these metal balls and external connections. Compared to before, the area has become smaller, and the number of pins can become very large. If it is a chip used in a mobile phone, this step is not enough. In addition to core computing, mobile phone chips also have multiple modules such as storage and baseband. In other words, multiple module chips must be able to communicate with each other and be integrated into a single package. The principle is to place all chip modules facing downwards. Place many small protrusions. Then place a silicon interposer and use chemical methods to etch circuits onto the silicon interposer. Furthermore, these lines are drilled through, and the lines are only 10 micrometers wide, approximately 1/10 the thickness of a human hair. Then place metal protrusions at the bottom to connect the wire carrier board. The circuitry on the wire carrier board is also perforated and connected to a large number of metal balls. This type of packaging is known as 2.5D packaging. Currently, Huawei and other chips use this type of packaging. As can be seen from the physical object, the metal balls on the back are very dense and closely spaced. When soldering PCB, tilt them slightly so that the metal balls can easily contact the pads. Therefore, mobile phone chips use SMT placement machines. Use machines to identify pad locations and accurately mount chips. Of course, it is impossible to determine with the naked eye whether the solder pad in the middle is accurately aligned. Therefore, factories use X-ray equipment, which works similarly to X-rays and can clearly show the internal contact status. Through this lens, even the smallest circuits can be clearly seen. The above is the principle behind common chip packaging. We believe that there will be more technological breakthroughs in the future.